Read the question carefully. In any case, the mass spring system is modeled by this IVP, initial value problem. mu double prime plus gamma u prime plus ku equals ft. Okay, this is the damping constant. K is spring constant, m is mass, u0 that has some value, initial displacement, u prime 0 that's initial velocity, some value, ft is the external force. So in this question, a 3 kilogram object, that's the mass 3, is attached to a spring and it will stretch this string 3.92 centimeter. So we need to divide by 100 to convert into meters, because meters and kilogram, they are in the same range. Divide by 100, you get 0.392. As soon as you have the stretched length L, we can find the spring constant K. K is weight mg over stretched length L. M is mass 3. G is acceleration due to gravity, that's in metric system 9.8, about 9.8, divided by 0.392, then it comes out to be 75. That's the spring constant K. There is no damping, this is gamma is 0, and a forcing function, that's the external force, tan cosine omega t, is attached to the object, and the system will experience resonance. So this omega will be same as natural frequency. Okay, this resonance means this omega, the outside function, forcing function W, this argument W will be same as natural frequency. Okay, so we'll do that in a moment. If the object is initially, that means initial things, initially displaced 10 centimeter downward, that's the initial displacement u at 0, 20 centimeter divided by 100, you get 0.2. So u0 initial displacement 0.2 from its equilibrium position, and given a velocity of 10 centimeter per second upward. Okay, upward means negative, so that's the initial velocity u prime 0, divide by 100, you get 0.1 meters per second. Okay, now find the displacement at any time t. So we need to find ut, solve this system. Okay, so we need to determine this omega, and we know that the system experience resonance, so this W will be same as omega naught. So omega is same as omega naught, and that is given by the formula square root of k over m, and that comes out to be 5. Thus the ODE, our ODE from, look at this right hand top, the ODE is m u double prime, so 3 u double prime plus gamma is 0, so move on. K is now is given 75, u equals right hand side is 10 cosine omega t, and omega is now 5, same as omega naught, so 10 cosine 5t. This is a non-homogeneous second order constant coefficient differential equation. To solve, we first consider the corresponding homogeneous. Just take right hand side 0 and find a solution, which is the complementary solution. To solve this, we find the characteristic equation, and that gives you r square equals negative 25, or r is plus minus 5i. Based on these roots, the solution, in this case complementary, because just the homogeneous part, is c1, or imaginary roots, so cosine 5t plus c2 sine 5t. Now based on this right hand side, since we have non-homogeneous, so we need to find a particular solution. So this is just a cosine, so we can use the method of undetermined coefficients. So we can guess, let u or particular solution be based on, this is a constant 10, so we can have any constant, cosine 5t. So whenever we have cosine or sine in the right hand side, so our guess will be a linear combination of both sine and cosine. So that will be a cosine 5t plus b sine 5t. Okay, provided these are not already the solutions. But look at this complementary solution. Cosine 5t, sine 5t are already there. So we cannot have this as a particular solution, because if we try with this particular solution, then we cannot determine the values of a and b. So we need to multiply through by t. So here's t. That's the u. Now we need to determine a and b. So next thing I do is find u prime, u double prime, and plug this back here in this ODE. No, not this ODE, here with non-homogeneous. So we go back here. Okay, we solve this homogeneous easily. Okay, since we have u, then let's find u prime using product rule. So we have a product of two functions. So this is u prime. Then find the second derivative, the derivative of this, and we have to use product rule here as well. Now, our goal is to determine a and b. So I factor t out here, and when I wrote here, I combine these two terms and these two terms. Okay, so let's plug in u prime, u double prime into the ODE. We don't need u prime, but to find u double prime, we have to go through this anyways. So plugging this u double prime into the ODE, we get, so we have 3 times u double prime plus 75 times u equals 10 cosine 5t. So let me write that. So we had the ODE 3u double prime plus 75u equals 10 cosine 5t. So we multiply this u double prime, this whole thing, by 3. Okay, just multiply this by 3 plus multiply u by 75. So this is u double prime plus 75u equals, right hand side is 10 cosine 5t. Now let's simplify the left hand side. As you can see, this negative 75t, everything, and this, they are same, so cancel. So we are just left with this equals 10 cosine 5t, and there is no sine, there is no sine 5t term. Okay, that means this negative 30a should be 0. In turn, a is 0. Okay, from this we get a equals 0, and 30b, that's the coefficient of cosine, that should be equal to 10. Okay, so 30b is equal to 10. That implies a equals 1/3. Okay, and b, my bad, b equals 1/3. Now we go back and find the particular solution here. So this was the particular solution. Now b is 1/3 and a is 0. This is gone. So 1/3 t sine 5t. Okay, so 1/3 t sine 5t particular plus here is the complementary solution, and the sum of these two will be the solution. Okay, thus the displacement at any time t is given by complementary plus a particular, which is c1 cosine 5t plus c2 sine 5t plus, now particular was here, and a is 0, so we don't have this. So b is 1/3 t sine 5t. Now we have yet to determine the constants c1 and c2. Okay, these constants c1 and c2 using the initial conditions. Okay, note that the initial conditions or initial displacement 0.2 and initial velocity negative 0.1. And to make use of this initial velocity, let's find the derivative of this displacement u. Here we need to use product rule, and this is the derivative of this function. And using the first initial condition, so using u at 0 equals 0.2, we get, let's go here, so u is 0.2 equals, let's plug in t equals 0, cosine 0, that's 1, so c1 plus c2 sine 0. Sine 0 is 0, so this is no value, 0. 1/3 times 0 is nothing, so c1 is 0.2. And using the second initial condition, u prime at 0 equals negative 0.1, we get, so we use here, by the way, here u prime is negative 0.1 equals negative 5 c1 sine 0, because t is 0, so this is 0, 5 c2 cosine 0, that's 1, don't have to write, plus 1/3 sine 0, that's 0, 5/3 times 0, that's 0, so negative 0.1 equals 5c2, that implies c2 equals negative 0.1 over 5, so 0.1 means 1 over 10, okay, so 1 over 10 means negative 1 over 50. So the final answer, the displacement at any time t, is given by here, c1 cosine 5t, c1 is 0.2 cosine 5t, plus c2, that's negative 1 over 50 sine 5t, plus 1/3 t sine 5t. Final